is the module 3 of thermodynamics. The module 3 is all about the ideal gas. Now, an ideal gas is ideal only in the sense that it conforms to the simple perfect gas laws. Now, there are different laws governing this ideal gas. And one of these laws is the Boyle's law. The Boyle's law, if the temperature of a given quantity of gas is held constant, the volume of the gas varies inversely with the absolute pressure during the change of state. Now, here, the Boyle's law said that if the temperature is constant, the volume of the gas is inversely proportional to its pressure. Meaning, your volume is inversely proportional to your pressure, which is denotes as 1 over P. So, therefore, if your constant is your temperature, we yield this kind of equation. And this kind of equation using your derivation in getting your PV, your constant, that this is your equation. Now, your P1 V1 equals P2 V2. There are there are certain types of problems that involves its final and its initial pressure and volume. So therefore, if there are given initial and final pressure and volume, you have to make this you have to use this kind of equation. Next, the Charles law. If the pressure in a particular quantity of a gas is held constant, then with any change of state, the volume will vary directly as the absolute temperature. Now, in Charles law, uh, the pressure the pressure on a particular gas is held constant. Therefore, its volume varies directly as the absolute temperature. Now, your volume varies directly proportional to your temperature. Meaning, when you are adding your constant here, you have yield this kind of equation. Now, your volume over your temperature equals your C, or your simply V1 over T1 equals V2 over T2. If the volume of a particular quantity of gas is held constant, then with any change of state, the pressure will vary inversely as the absolute pressure. If the pressure is held constant, no, if the volume is held constant, rather, the pressure is directly proportional to absolute pressure. Meaning, your temperature is directly proportional to your pressure. So here, when the pressure is constant, your volume is directly proportional to your temperature. Whereas here, if your volume is constant, your pressure is directly proportional to your temperature. Now, for better understanding, we combined the the Charles law and the Boyle's law in into this equation of state or characteristics equation of the perfect gas. The combination of the Charles law and the Boyle's law is your perfect gas. For better simplification, we have here your perfect gas equation. Your perfect gas equation is P P P1, okay, P1 V1 over T1 equals P2 V2 over T2. Sorry. Now, over T2. Now, in Charles' law, it's stated, I'm sorry, in Boyle's law rather, the temperature of a given quantity of gas is held constant. Therefore, if the temperature is constant, your temperature is 0. So meaning, if your temperature is 0, we have to cancel this T1 and this T2. Therefore, the equation left would be your P1 V1 equals P2 V2, which is here. Now, let's back. Let's go back to the original equation, the perfect gas equation. Now, in Charles' law, if the pressure of a particular quantity of gas is held constant, Then, with any change of state, the volume will vary directly as the absolute temperature. Now, in Charles' law, if the pressure is held constant, so meaning your pressure is zero. So this pressure 1 and pressure 2 is being cancelled. Therefore, you only have left equation is V1 over T1, which is this, and V2 over T2, which is this. Okay? Next. Uh, hmm, Now, next. In another case of the Charles law is if the volume of a particular quantity of gas is held constant. So therefore, if the volume is constant, we have volume 1 and volume 2 is 0. So therefore, you canceled out its volume. All we have left in the equation is P1 over T1, which is this, and P2 over T2, which is this. So that is the concept of the Boyles law and the Charles law. I will delete it first. Okay. Okay. Next. Uh, Now, another thing in the perfect equation of if the perfect gas. Now, combining Boyle's law and Charles' law, we have this kind of constant. Now, after that, we can derive the equation on here. Your PV over T equals MR. So when you say MR, this is your mass. This is your constant. If the problem has a given mass and given gas, each gas has its own R. Therefore, deriving this formula, we yield PV equals MRT. So therefore, your perfect gas equation is PV MRT derived from your combination of your Charles law and your Boyle's law. Now, for better understanding of the concept, let's solve problem exercise number 1. Now, a drum 6 inches in diameter and 40 inches long contained acetylene at 250 psi and 90 Fahrenheit. After some of the acetylene was used, the pressure was 200 psi and the temperature was 85. Now, this is the question. What proportion of the acetylene was used? What volume would the used acetylene occupy at 14.7 psi and 80 Fahrenheit, where R, gas constant, for acetylene is 59.35 feet pound per pound degree Rankine. Now, in the problem, we will be using its given R, given gas constant. In every problem, there should be given gas constant. So now, what are the givens? The given are a volume, with the diameter, which is 6 inches, and 4 inches long. Now, then we have given also a pressure 1, which is 200 psi, 250 psia, and temperature 1, which is 90 Fahrenheit. Next, your pressure 2, which is 200 psia, and your temperature 2, which is 85 Fahrenheit. Now, the question in letter A is what proportion of the acetylene was used? Now, our mother equation, our general equation for this kind of question is M1 plus M2 equals M3. Why? Because the question here is what proportion of the acetylene was used? And we only have given two. We have only two conditions. It's pressure and volume contained acetylene, and after the acetylene was used, we have given also its pressure and its temperature. So therefore, we have first to know what is the total mass with what is the total mass of the acetylene. So therefore, we have to add the acetylene and the acetylene used for us to know the total acetylene. So therefore, your M3 equals M1 plus M2, which is M1 is your acetylene, your contained acetylene, and M2 is your acetylene used. So therefore, in solving mass, we have the equation, the perfect gas equation. We have the perfect gas equation, PV equals MRT. Now, to be able to solve for M1, we have to derive. So therefore, your M is PV over RT. Now, here in your mass, your P1 V1 equals over RT1, your mass 1. So therefore, where is my calculator? Okay. Now, therefore, your P1 is 250 psi. Now, next, your V1 is we don't have volume. All we have is your diameter and your height. So therefore, to be able to compute for your volume, we have to use the equation volume of the drum, which is pi d squared over 4, which is your area, times your height, which is your length. Okay, height or length, anything. So therefore, your pi times your diameter, which is 6 inches, over 2, or raised to 2, over 4 times 40. Now, your answer, pi times 6 squared over 4 times 40. So therefore, you have 360 pi. 360 pi inches. But the standard English system that we're going to use must be in feet. So therefore, you have to convert your 360 pi inches into feet, which is you have to multiply it by 12 also. Because 12 inches is equal to 1 feet. So therefore, your 360 pi should be divided into 12. And your answer is, sorry, since it is inches cubic inches, since it is volume, you have to convert it into cubic feet. So therefore, your 360 pi divided by 12 cube. So therefore, you have yield 0.654498, so on and so forth. Now, you have to store it on your calculator for later use. So I will go into erase first this equation, this solution. Now let's go back to the equation here. Your 250, your PSI, your P1, and your volume, which is your 0.065 0.6545. Then this is feet. Since it is PSI, you have to multiply it also by a conversion factor in multiply by 144. All over your given constant R, 59.35 feet per pound degree Rankine. Then, your temperature, what is your temperature? Your temperature, T1 is 90 degree Fahrenheit, but this is not in Rankine. So, the absolute temperature in Rankine, in English system is Rankine. So, our conversion, Our conversion for Fahrenheit to Rankine is plus 490. So therefore, 460. So 90 plus 460 is equal to 550. So therefore, you have 550 Rankine, degree Rankine. So we need to cancel unnecessary units. This is inches squared. So you have to cancel inches squared. You have to cancel inches squared here. We have to use pounds this. Yeah. This cancel here. Cancel this. This is feet. Cubic feet. So we have to cancel the feet here and the feet here. Then all we have left is pound. Okay. All you have left is pound. Your mass 1 equals your, simplifying, 250 times 6 times alpha A times 144 all over 59.35 times 550. Your answer is 250. 59.35. So the answer is 0. The answer is 0.721818. Now that is your pound per pound. Now this is the mass 1 only. Now in mass 2, it's the same process. So all you have to do is to substitute the value for your mass 2. We have mass 2 here, mass 2 here, temperature 2 here. So therefore, your pressure 2 is 200 psi multiplied by your 144 conversion factor multiplied by your volume, which is 0.65 all over your R, which is 59.35, and your temperature, absolute temperature. Don't forget to change your temperature into an absolute temperature. So therefore, your mass 2 is 550 is 0.5774 pound. So all you have to do is to store it also. Store, store for your calculator, on your calculator. Now, we have mass 2 and mass 1. So therefore, we can solve your M3. Your M3 equals mass 1 plus your mass 2, which is your total. M3 is your total masses. So your stored values, your mass 3 is 1.29. No, where this is not a total because the question, the proportion only of the acetylene used. So therefore, your mass 1 should be subtracted to your mass 2 because the problem is asking what is the acetylene used only, not the total acetylene. So therefore, you have to subtract. I'm sorry. You have to subtract it. So therefore, your mass 1 minus your mass 2 is equal to 0.144. So mass 2 equals 0.14436. So that's it, your mass 3. Now you have to store it also on your calculator for later use. Because the next step that we're going to use is to solve the acetylene used. So therefore, using proportionality, no, using proportions, we have to determine the percentage per volume. So therefore, this is your per mass. So all we have to do is to find the proportion, which is when we say proportion, the percent. So therefore, your mass 3, which is 0.1, all over your mass 1, which is your contained acetylene in the tank. So therefore, 0.144 all over your stored value 1 point 0 sorry 0.7218. Your acetylene used in percent should be equal to 0.2% or 0.2 or 20% or 20%. Therefore, your proportion of the acetylene used is 20%. Okay? So that's the application of the perfect gas law. Now, letter B. What volume would be used acetylene occupy at 14.7 psi and 80 Fahrenheit, where R for acetylene is 59.35. So, what is the volume? You have given your pressure. Our mother equation would be PV equals MRT. Again, your pressure is 14.7 psi. Converted it into cubic feet. Into feet squared equals your mass, which is your mass to be used is 1.44. Then your R is 59.35. Then your temperature, which is 80 degree converted into your degree Rankine, absolute temperature is 540. Therefore, your volume equals 2.105 cubic feet. That is your volume. That is the application of your perfect gas laws, your Charles law, and your Boyles law. Next, your specific heat. Your specific heat, the specific heat of a substance is defined as the quantity of heat required to change the temperature of unit mass through 1 degree. So therefore, using this equation, your constant heat energy units per mass. So therefore, in in differential equation quantities, your constant would be your derivative of heat, all per mass with respect to time. So therefore, simplifying, dq equals mc dt. So therefore, you have, since q, we have to transpose or to simplify this equation. So therefore, we have an integration of m with limits 2 to 1, derivative of constant with respect to time. I'm sorry, derivative of, CDT. Okay, which is the specific heat equation. Now, if we will simplify this equation, this equation will yield on this. Your Q would be your MC equals, multiply by, your Q will become Q equals, upon simplifying, your Q will become MC T2 minus T1. Now, in the problem, if you're going to find your specific heat, this is your equation to be used. Your Q equals MC T2 minus T1. Now, your T2 and T1 is your, T2 is your final and your T1 is your initial. Now, your constant volume specific, your CV. There are certain problems that will have the value for CV. And there are certain problems that it didn't have. So therefore, you have to compute also for your CV using these kind of equations. Now, in constant volume, the constant here would be CV. And now, in constant pressure, the constant value that we're going to use is CP. CV and CP are different. Now, its values should not be part of the problem, but you have to memorize it because there are certain problems that it doesn't give the value for CP and CV, but there are certain problems that will give. Like for example, if the problem will not give a CP or CV, therefore you understood it in at standard condition. You see, at standard condition, the CP and CV would be the air. So therefore, your CP and CV of the air must be known. You have to know the CP and CV for your air. Now, for problem exercise, for better understanding, your problem exercise number 1. Now, for a certain ideal gas, where R is 25.8 and K is 1.04. Now, what are the values of CP and CV? Now, in your equation, in your formula, we have formula for getting CP and CV. Your CP, okay, CP equals KR over K minus 1. So your K is given 1.9 multiplied by your R, which is 25.8, all over your K, which is 1.9 also, minus 1. Therefore, your CP rather, is 0.09 times 20 by 30 is 312.47 feet-pound per pound Rankine. Now, if you're going to convert it into BTU, you have to divide it by 778 because 1 BTU equals 778 feet-pound. So therefore, upon dividing it on 778, your CP would become 0.416 BTU per pound Rankine, degree Rankine. That is your CP. Now, next, your CV. So since we have CP, we can easily get your CV by using the equation CV equals CP over K. Because K equals CP times CP. Okay? So therefore, 0.4016 all over K, which is 1.09. Your CV is your CV 0.30 0.3684. Your CP is 0.3684. So next, we have letter B. In letter B, what mass of this gas would occupy a volume of 15 cubic feet at 750 psi and 80 degree Fahrenheit? So therefore, using your equation, PV equals MRT, we can get the mass. Your pressure is 75 psi. You have to convert it also into feet squared. Your volume, which is 15 cubic feet, equals your unknown mass, your R, which is 25.8, multiplied by your temperature, which is 80 Fahrenheit plus 460, to convert that into your absolute temperature. Therefore, your mass is 11.63 pounds. Now, therefore, your mass is 11.63 pounds. Okay, now let's go to letter C. Letter C, if 30 BTU are transferred to this gas at constant volume in B, what are the resulting temperature and pressure? Now, using the equation, your specific heat, Q equals MC V. Why? Why we use CV? Because it's stated that it is in constant volume. Now, if the problem stated in constant pressure, we are going to use CP. So here in this case, we are going to use CV. So MCV T2 minus T1. Now, the mass we're going to use is we solved on letter B, 11.63. Multiply by your CV, which we solved also. So you have to store it, which is 0.3685. Then your temperature, T2. Your temperature T2 is the unknown value. And your initial temperature would be 540, since 80 plus 460 is 540 because volume in letter B. We based this letter C in the values we obtained in letter B. Then, if there are 30 BTU heat to the gas, therefore your heat is 30 BTU. So therefore, your T2 is equal to 547 degree Rankine. This is your temperature, resulting temperature. Now, what is your resulting pressure? Now, we have the equation P1 over T1, P2 over T2. So therefore, your resulting pressure, if we derive, we obtain an equation P2 equals P1 multiplied by P2 over P1. Substituting the equation, we have P1 which is 75 psi multiply by your T2 which is 547 and your T1 which is 540. Therefore, we have obtained the resulting pressure which is 76 psi. So that's it. The problem number 1, we solved the temperature. The resulting temperature which is the T2 and the resulting pressure which is T1 using our perfect gas equation. Okay, let's go back to the last topic, which is the entropy. Entropy is the property of a substance which remains constant if no heat enters or leaves the substance, while it does work or alters its volume, but which increases or diminishes should a small amount of heat enter or leave. The change in the entropy of a substance receiving is defined as this kind of equation, which is the limit of 2 to 1 derivative of Q per T. Now, your dQ is heat transferred at the temperature T, and your delta S is your total change of entropy. Now, your total change of entropy would be like this equation. Your limits to final and initial, mc dt over T. So now, your temperature would become Q equals TDS, which is your temperature. So therefore, upon deriving on the equation, you have this kind of, sorry, upon deriving, we have this kind of formula. We result to this kind of formula. Your delta S would be your MCLN T2 over T1. I will not show you the simplification of this integration, but the template for this kind of integration would be ln T2 over T1. And we have your MC since it is a constant. So therefore, your delta S or change in entropy is MC ln T2 over T1. Now, in temperature entropy coordinates, your Q, the area under the curve of the process on the TS plane represents the quantity of heat transferred during the process. Now, this is your TS diagram. So this is your temperature. So therefore, your heat, for us to be able to know the area under this curve 1, 2, we have to know your dt and your ds. So therefore, your TDS is your Q. Right? And that's it for the module 3, which is the ideal gas. So therefore, it's very easy for us to know the concept of the ideal gas since we only have at least four problems, which is the, four concepts, which is the Boyles Law, which is at constant temperature, and Charles Law, which has two cases, the constant pressure and the constant volume. And then upon combining this Boyles Law and Charles Law, we have your perfect gas equation. And upon simplifying the combination of Boyles Law and Charles Law, we yield to a perfect gas PV MRT. PV equals MRT. Now, your PV equals MRT is very important, or let's say that is your general equation for the whole problem. Then, after that, we also discussed the topics for your specific heat. Your specific heat has CP and CV. Now again, if the problem is stated that it is in constant volume, you have to use CP, whereas if the problem is stated at constant pressure, you have to use CP. And that's it. There are more problems to be discussed on this module 3, so please stay tuned on this video. Thank you.